Escherichia coli is a well-known bacteria which is commonly found in the intestine tract of humans and other warm-blooded animals. E. coli is undoubtedly the most common host microorganism for production of different types of recombinant proteins, especially for pharmaceutical industry. A lot of drugs and vaccines are available in the market that are produced through E. coli fermentation process. Traditionally, E. coli fermentation is carried out in batch culture. However, in a batch process, productivity is limited by initial concentration of substrates or certain medium compounds. On the other hand, too high substrate concentrations may cause substrate inhibition or high cell-specific substrate uptake rate, leading to increased production of partially oxidized byproducts like acetate. Hence, fed batch culture was proposed as an alternative. Differ from batch culture. In fed batch culture, limiting factor is supplied during the cultivation process. Fed batch culture is one of the most important form of operation in E. coli fermentation, and it has been extensively applied for production of various kinds of biological products. Since in a fed batch process a flow of feed is continuously added during the course of fermentation, the question of how much should be the flow rate arises. We know that feed flow rate can change the concentration of substrate and other components of the culture as well as the viscosity of the liquid medium. So, in addition to factors like temperature, dissolved oxygen, impeller speed, feed flow rate should be controlled as well. Like all other parameters of a process, feed flow rate can be controlled through one of three main strategies: feed-forward control, feedback control, and feed-forward feedback control. Feed-forward control is a type of control algorithm which is independent of fermentation variables, and its response is based on prior understanding of the system and disturbances. In feed-forward control algorithm, feed flow control is applied based on a predetermined function of time. According to this functionality, feeding strategy models can be divided to four main categories: constant, linear, and exponential increase in feed rates, and pulse feeding. On the contrary, feedback control algorithm response depends on its measurement as a feedback signal. This feedback signal is compared with a predetermined reference to produce an error signal, which is subsequently filtered by a controller to generate the system's control input. For a typical E. coli fermentation, feedback control can be applied based on pH of the media, or based on dissolved oxygen concentration, or based on substrate concentration. The last main type of control algorithm which can be potentially used for feed flow rate control is feed-forward feedback control, which is a combination of feed-forward control and feedback control. Two general categories of feed-forward feedback control are introduced in the publications based on the state observer that is used in the algorithm. The first category is on the basis of the classical observers, which are based upon the perfect understanding of both system parameters and model structure. But, the second category, known as asymptotic observers, does not need the process kinetics data. In the article with the title of "A Review of Feeding Strategies for Fed Batch Fermentation of Escherichia coli," Feeding Strategies for E. coli Fermentation in Fed Batch Culture was reviewed, classified and compared, and almost all the previous reports that have been done in the past decade on E. coli fermentation by fed batch cultivation were categorized according to the explained classification.